Hello friends, let's discuss today a very interesting topic called El Nino and Southern Oscillation, or otherwise termed as Enso. Right. The image that you are seeing is a combination of temperatures of different months of an year. Right. That is especially from 2015 to 2015 and 16. Right. What you can see is this red bubble, right, that is coming up here, right? It is moving towards the eastern Pacific, and the disappearance of blue from here, that is something what we call as the El Nino phenomena, right? So it is pronounced as El Nino, right, than El Nino as such, but it's okay, so whatever way you pronounce, but it's good to understand what the phenomena is all about, right? So let's try to understand why this thing happens, right? So El Nino is nothing but a temporary phenomenon wherein it results into a warm current flowing along the coast of Peru during December months. Now, as you already know that along the Peruvian coast we have a cold current which is termed as Peruvian current or the Humboldt current. So this current actually moves towards the equator, right? That is the normal condition. Now this current reverses during certain periods and flows from equator towards the southern side, right? So, and the temperature of the current also changes, it becomes warmer. So that change is termed as El Nino, right? So this was actually discovered by Sir Gilbert Walker in 1920. He had actually discovered the phenomena of differentiation in pressure between the equatorial southern Indian Ocean and equatorial southern Pacific Ocean. So this pressure difference is something that he understood and he started interpreting. I'll just explain to you what is the pressure difference that is happening, right? So what Gilbert Walker says is that whenever there is the ocean pressure is high, or we can say whenever there is a high pressure here in Indian Ocean, there is a low pressure here in the equatorial South Pacific, right? And similarly, whenever there is low pressure here in equatorial South Indian Ocean, there is high pressure here in the Pacific Ocean, right? So this keeps on changing, right? So sometimes there is high pressure here, there is low pressure here, sometimes there is high pressure here and there is low pressure here. So this keeps on going, keeps on changing. So this pressure variation is stated as Southern Oscillation Index. So this pressure variation that keeps happening between the South Equatorial Indian Ocean and South Equatorial Pacific Ocean is termed as SOI, Southern Oscillation Index, right? Now, the pressure variation also gives rise to a circulation, right, which is termed as Walker circulation. So let's look at what Walker circulation is. Walker circulation. This is after Gilbert Walker, right? Okay. So the pressure differentiation is actually calculated right? So somewhere we have to measure the pressure differences, right? So in Pacific Ocean it is normally measured at Tahiti Island, and in Indian Ocean it is measured at Port Darwin in Australia. So based on which things happen. Now another thing that you should remember here is the wind pattern here. So normal wind pattern is what? So here you have southeast trades, and here you have the northeast trades, right? Northeast trades, and you have southeast trades. So in normal conditions the trade winds are good enough, and as the southeast trade, as it moves towards the equator, it does tend to bend towards east, and by the time it reaches the you can say western part of the Pacific Ocean, it is near about easterly in direction, and so it is flowing from southeast to northwest direction, right? So it normally in southern hemisphere it keeps deflecting towards the left, and thus it reaches the western Pacific in a near about easterly direction. So now what it does is it pushes the water, right? It pushes the water here and creates the equatorial south equatorial current, right? And there is lot of piling up of water that is happening here, right? So it happens in entire so there is northeast trades here that also push the water towards this side. So there is huge piling up of water that is happening here, and this water is warm water, right? So warm water getting piled up in the western part of Pacific. So what does this do? So this will result in convection currents, right? So there will be convection currents which will take lot of evaporation or evaporated material up, and thus there will be cloud formation, right? So cloud formation means there will be heavy rainfall as well, right? So this is the normal situation, and as the air rises up it will cool down and then it will start diverging away. So there is anticyclogenesis here. So this current that moves, or the air that moves in the upper regions, then slowly descends down as dry air in the eastern Pacific, right, along the coast of South America. So this circulation is what we call as, this entire circulation is called as Walker circulation. So this is the normal condition. This is the normal state of Pacific Ocean. So this is a normal circulation that we find in Pacific Ocean. Walker circulation is a normal thing that happens here. Now there is another thing that happens here as well, right? Which you know. So here there is offshore winds, so there is pushing of water that is happening along the coast, and thus there is a lot of upwelling that happens here, and you will find a cold current. Sorry, I've drawn the direction wrongly, right? So then there is a cold current that arrives here, right? So you have lot of upwelling that is happening here, because all the water from here surface is driven towards the western Pacific, and this results in upwelling of water. That is, cooler water tend to come up on the surface. So this is termed as the Peruvian current, right? Peru current, right? Peru cold current. So this is normal scenario. So this is normal scenario. So you have a Walker cell going on. The Walker cell results in pushing off, or the trade winds results in pushing off water towards the Western Pacific, and that results in upwelling, and there is a cold current going on, right? So this is the normal way the Pacific Ocean behaves. Now, sometimes the trade winds are very strong, right? So this is another picture that shows you the same thing. So here it is South America, and this is Pacific, right? Pacific Ocean. So there is pushing of water towards the west. Clouds form. There is heavy rainfall here. So there is all these typhoons and cyclones and such kind of things happening in these areas, right? And there is the fairly steep where thermocline is there, and this results into upwelling in the coastal areas of South America, and that is eastern part of Pacific, right? So this is the normal cycle that is going on. Sometimes what happens is that this situation gets extended, so it goes on a what you call longer drive, you can say, or overdrive, you can say, right? So that situation is termed as La Nina, right? So extended normal condition is termed as La Nina. So what is happening here is, so the trade winds are stronger, and it pushes more amount of warmer water, and this warmer water enters into the Indian Ocean area, especially the islands here. So to these areas it enters. So this is all Indian Ocean area, and there is a huge cloud formation here, right? Huge cloud formation here, and there is heavy rainfall that happens, and you'll find the frequency of cyclones, the typhoons, something that is called in China and the Southeastern Asian region. So these increase at huge amount. Of this can be seen. And similarly, the cold water, the upwelling is very high. The thermocline becomes steeper. Right, thermocline was a comparatively gentler one when normal conditions exist. So here thermocline becomes steeper, and there is strong upwelling that is happening, and because of which entire coastal waters, including towards the northern hemisphere, right, northern tropical areas, the cold waters start entering, and so entire this area, coastal areas, will be having drought-like conditions. So this extended period of La Nina, extended period of normal condition is referred to as La Nina conditions, right? So you can see huge wind patterns, huge strong winds happening, and a strong upwelling happening. Now what happens here is, along the coast of South America, you have deserts here, and they face acute drought condition. All the areas you will find very acute drought conditions along the coastline because of cold current, dry conditions, dry winds, no rainfall. So you will find drought-like condition or dryness in the air. Similarly, in the USA as well, or North America as well, you will find dry conditions. Here you have the Californian desert, Mojave, the Baja Peninsula, all those areas. So you'll find very high dry conditions in existence. And on the other hand, the Western Pacific will be having torrential rain, cyclones, and disasters, etc. So this is the normal conditions at extended phase, which we termed as the La Nina condition. Now, it does result in lots of flooding, especially in these areas, the Western Pacific, right? Or Indonesia, China, those areas, right? Now, when the during the El Nino phase, what happens is the it is just the opposite of what is happening in normal or La Nina phase, right? So La Nina phase, you have very high warm conditions that are in existence here. So here what is happening is the warmer waters from here, right? The warmer waters from here start moving towards Eastern Pacific. Now this is as a result of weaker trade winds. So trade winds are weak, and they are unable to push the water, the surface water, towards the Western Pacific. So the temperature conditions change, the upwelling nearly gets stopped, so there is no upwelling along the coast, and it results into shifting of this warm area into Central Pacific initially, right? So the warm area is here, and what happens is the circulation entirely breaks up. So you'll find a weak trade wind happening, and the convection is happening in the Central Pacific, and you'll find a huge amount of rainfall occurring here. So the what you call the circulation, the Walker circulation splits into two cells, and this warm area keeps on shifting towards slowly shifting towards the Eastern Pacific, and at a later stage what happens is that the cell is completely reversed, and you'll find the warmer waters are located here, or the entire this area becomes huge warm waters occupation, right? So the entire reversal happens. So here whatever cold water is there, it will start downwelling, and there will be upwelling happening in this side. So you'll find cooler waters coming up on this side. So what is happening is the entire circulation, right, is getting reversed. So entire circulation gets reversed, and you have cloud formations here, right? Cloud formations happening here, and there will be heavy rainfall. So this rainfall may will be affecting the coastal areas and all. So this is the El Nino phase, wherein you have rainfall happening in Atacama Desert. So the complete reversal of La Nina phase is termed as El Nino, right? So this is another cross-sectional diagram which shows the shifting of so the warm area was here, warm water pool was here, so it has shifted to the what you call Central Pacific, causing huge rising air and huge torrential rainfall here, and this slowly actually shifts, this also shifts towards the Eastern Pacific, and then at a later stage by December it occupies this particular area right along the coast, and there is a downwelling that happens here, and there is upwelling in the opposite side, that is the Western Pacific. So the complete the Walker cell gets completely reversed, right? So this, so you have the Walker cell so initial Walker cell, so this is the new Walker cell, El Nino Walker cell, right? In normal condition it is like this. Right, so normal condition you have cloud cover, rain, etc. in the normal condition, and this is during El Nino, right? El Nino phase, right? So the entire reversal, this is what is called as El Nino phenomena. Now, so normally so this explains to you, this map also explains to you in a better manner. So you will find the movement of warmer water along the coast. So this entirely disappears, the cold current entirely disappears. So there is downwelling here and there is upwelling here in this area. So what as a result, what is happening is you'll find a huge amount of rainfall happening in these areas, right? So because there is a huge amount of cloud cover that happens over South America, along South American coast, resulting in huge amount of rainfall, right? So the phrase that is normally used is the desert blooms is associated with what you call plants germinating in Atacama Desert and flowering for a short duration of time. So that is as a result of El Nino phenomenon, right? So this is what El Nino phenomena is. And during El Nino year, you will find the southern oscillation index is negative, and the pressure at Darwin, Darwin is somewhere here. So pressure at Darwin is higher than the pressure at Tahiti, right? Than that of Tahiti. And when the pressure conditions is lower in Indian Ocean in the winter season, it indicates that the chances of monsoon being good. So if the pressure conditions are lower here, so if the pressure conditions are lower here in Indian Ocean, right, the chances of having good amount of monsoon is always there. But when this changes, you'll find the scenario also changes, right? Especially this particular area, you'll find higher. So this keeps, as the sun travels, this keeps shifting northwards as well. So that is what results into good amount of monsoonal rainfall, right? Now there are hundreds of studies available with regard to rainfall related incidents. So a study of 100 years of rainfall, that is from 1870 to 1970, of Indian monsoons shows that around 43% deficient years, and of these 43 deficient years, 19 were directly associated with El Nino. And on the other hand, there were 6 El Nino years when there was above average rainfall as well, right? Similarly, there was a study, a meteorological study of 1972-73 period to and 2013-14 period. So from 1972-73 to 2013-14, there was a huge time related study, rainfall related study, and that shows that there were 14 droughts in this short period, right? 14 droughts that have happened in this short period, and of which 9 were El Nino years. So that shows how much influence it is happening. Now there is also another catch to it. On the other hand, right, 1991, 92, 94, 95, 97, 98, 2004, 2005, 2006, 2007. These were years of severe drought, and during those years you will not find El Nino in existence, right? So there is a certain contrasting things also happening. So there are local things also that are under influencing. So I hope you the El Nino phenomena is clear to you, and also about the southern oscillation related stuff, right? And in case you have any queries on this, I request you to post it on the Google Classroom itself, so that it is beneficial for other students as well. And I would like every one of you to post some comments that at least you have seen the video, you have understood it, right? So it becomes easier for me to know whether you are understanding things or not, right? So thank you and bye bye.